Hey everybody, this is Mr. Walsh, and I'm going to go over how to apply the combined gas law. That's this thing right here, the combined gas law. Okay, and this has all the three other laws in them. So it has Boyle's law, Charles' law, and Gay-Lussac's law. Okay, so there's definitely a process that you can use to help yourself get these answers down right. So let's take a look and let's give a start here. So it says a sample of oxygen occupies a volume 250 milliliters and its pressure. So this is a volume and this is a pressure. Now I put a 1 here because this is what it is at the beginning. Remember here, this is the beginning conditions, and this is the ending conditions. Okay, and it says, what is the new volume? So that's what we're trying to find when the pressure is increased to 800. So this is going to be P2. Okay, so what I'm going to do is I'm going to put the data down here: P1, V1, T1, P2, V2, T2. Okay, so we don't have temperature in this. We just have volume and pressures. So I'm going to get rid of those. And then the first volume is 250 milliliters. And the first pressure is 720 millimeters of mercury. And then the second pressure goes in here is 800 millimeters of mercury. Okay. So now we take this, and because this doesn't have temperature in it, let's see. So we would do P1 V1 over T1 equals P2 V2 over T2. These two go away. Now we can just plug the values into these things. So we get 720 times 250 equals P2, which is 800 times V2. So to solve for V2, we're going to divide both sides by 800, and we do the math. Okay, so I'm going to do 720. Make sure it's 720 times 250 divided by 800. When we do that, we get 225 equals V2. So, and that's going to be milliliters. Okay, and now we just want to double check what's happening to the pressure. Pressure is going up, so that means the volume is going to go down, and that's what happens. Okay, so now let's take a look at this next problem. It says a sample of helium has a volume. So again, this is volume and a temperature. Okay, so that's at the beginning, and then the volume is increased to 0.75. So I'm going to put P1 V1 T1 here, and then P2 V2 T2. Okay, we don't have any pressures in here, so our volume is 0.5, our temperature is 870, and our new volume is 0.75, and we want to know what the temperature is going to do. Okay, so again, we write the combined gas law, P1 V1 over T1 equals P2 V2 over T2. And because we don't have pressure, we're going to get rid of this. And so now this goes to, when we plug it in, we get 0.5 over 870 equals 0.75 over T2. So what we're going to do now is we're going to cross multiply this. We're going to use what they call the butterfly method. So we're going to take these two and we're going to put them together, and then these two and put them together. So we get 0.5 times T2 equals 0.75, make sure it's right here, times 870. Okay, so now this looks just like the problem we had up here. It's solved a little bit different, but that's how we do. So now we're going to divide both sides by 0.5, and now we plug it in the calculator. Okay, so 0.75 times 870. Make sure you can see it here. Divided by 0.5, and so we get that T2 is equal to 1305 Kelvin. Okay, so question 3, we're going to set all of these up the same way. Okay, so we do P1, V1, T1, and then P2, V2, T2. So this is P1 is 2.5, and volume is 380 at a constant temperature. So that phrase, constant temperatures, means that we can get rid of temperature in our stuff. What is the volume at 1 atmosphere? So we'll change this, and so we want to know what the volume is. So again, we'll use the ideal gas law, P1 V1 over T1 equals P2 V2 over T2. And we don't need temperature, so we're going to do 2.5 times 380 equals 1.0 times V2. Okay, so now we divide both sides by 1.00, which I hope y'all can do in your head, right? It's the same. So now we're ready to plug in the calculator. So 2.5 times 380 divided by 1, and that's going to be 950. Okay, so the volume is equal to 950 milliliters. Okay, so here we go. At what temperature will a quantity of gas? So let's see, P1, V1, T1, P2, V2, T2. So again, we're just putting in the parts of the combined gas law. So we'll do P1, 780, T1, 298. Okay, and notice volume isn't mentioned, so we're going to get rid of that. And the new pressure is 700, and we want to know what the new temperature is going to be. So temperature is affected by this. So again, P1 V1 over T1 equals P2 V2 over T2. We don't need V, so we're going to go 780 over 298 equals 700 over T2, and then we're going to butterfly this because we want to cross multiply. Okay, so we get 780 times 298 equal 700, because this is 700 times 298 equals 780 over T2. Okay, so now we divide both sides by 780. Now we have a problem that looks like the ones that we've solved up here. Divide both sides by 780. Okay, and now we calculate. So we do, let's clear this. So we do 700 times 298 divided by 780. Okay, and we get some crazy number, 267.4. I'm just going to round to the first decimal place, the 10th spot, and then we want the unit So that's going to be K, okay, because it's a temperature. Okay. Okay, 2 more to go here. Okay, so again, P1, V1, T1, P2, V2, T2. Okay, and so we have, this is a volume, 284 at 298. And it will occupy a volume at 248 Kelvin. And we want to know what the volume is. So pressure remains constant, so we don't have to worry about that. So again, we'll do P1 V1 over T1 equals P2 V2 over T2. We don't have to worry about pressure. And then when we plug this in, we get V1, 284 over 298 equals V2. So V2 we don't have, and then 248, and then we can butterfly this, cross multiply. So we get 298 times V2 equals 248 times 284. This one's a little confusing because there's lots of 2's and 8's in there, but we still do the same thing. Divide both sides by 298. 298. Okay, now we're ready for the calculator. So we're going to go 248 times 284 divided by 298. Okay, it's 236.3. 236.3. Okay. Oh, that unit will be milliliters. Okay, now the last one. Okay, a gas is contained in a flask. So, okay, P1, V1, T1, P2, V2, T2. Okay, that's a temperature, and that's a pressure. So 290 times, and then 780. Okay, and then the gas is heated to a temperature of 323. I can write here. And we want to know what the new pressure is. So the volumes cancel because we're not calculating anything with that. And so we're going to do P1 V1 over T1 equals P2 V2 over T2. And then, again, volume is not part of this. So we do 780 over 290 equals the pressure over 323. And we're going to butterfly this so we get 290 times P2 equals 780 times 323. Divide both sides by 290. Okay, and now we plug it in. And we get 780 times 323 divided by 290. And we get 868.8. And that's equal to our pressure. That's millimeters of mercury equals the pressure. Okay.